This is Algebra Lesson 7-3, Solving Systems by Elimination. Elimination is a method for solving systems of equations. The goal is to add the equations together to eliminate a variable. It's easiest to use the elimination method if the equations are written in standard form. ax plus by equals c, which means if they're not written in standard form, you need to rewrite them in standard form before you try to eliminate a variable. Let's look at a couple of examples here. As I did with the substitution method, I like to number my equations 1 and 2 because it makes it easier to refer back to them. So I have two equations here. I have equation 1, which is 6x minus 3y equals 3, and I have equation 2, which is negative 6x plus 5y equals 3. If I look at these two equations, I can see right now that if I added these two equations together, 6x would have, all the x's would get eliminated because 6x and negative 6x is 0x, and 0 times x is 0. So the whole goal of elimination is when you add your two equations together, a variable gets eliminated. Sometimes you can just add them together and a variable gets eliminated right away. Sometimes you have to manipulate the equations first to get rid of a variable. So if I look at these two, I'm just going to add these two equations together. 6x and negative 6x cancel out. I have negative 3y plus 5y, which gives me 2y, and 3 plus 3 equals 6. So now I have 2y equals 6 to solve for y. Divide by 2. So y equals 3. Once I have my equation solved for y, I can substitute y back into either equation 1 or equation 2. I'll put it back into equation 1 because it's pretty simple. So I have 6x minus 3 times 3 equals 3. So 6x minus 9 equals 3. Add 9 to both sides. 6x equals 12. Divide by 6. So x will equal 2. And just like our other equations, the solution is always written as an ordered pair. So it's 2, 3. And just like our other types of problem solving, I can substitute that back into my original equations to make sure it makes a true statement. If I substituted 2, 3 into the first equation, I would have 6 times 2 is 12, minus 3 times 3, which is 9, equals 3. That is true, so it works. Into my second equation, negative 6 times 2 is negative 12, plus 5 times 3 is 15. Negative 12 plus 15 is also 3, so it checks. In my second problem here, I still have two equations, equation 1 and equation 2, but if I added them together, nothing would get eliminated. I would have 10x plus 9y equals 56, which doesn't do me any good. However, since the x's are the same, 5x and 5x, they have the same coefficient, 5, it would be very simple to take one of those two equations and multiply it by a negative 1. And it doesn't matter which equation I do that to. I'll just do it to the top equation, and I like to do that by showing it like this. So I'm going to multiply everything in equation 1 by negative 1. That will give me negative 5x minus 3y equals negative 22. Equation 2 I'm going to leave alone, so I don't write it up above my little arrow what I did, because I didn't do anything, so I have 5x plus 6y equals 34. Now if I add these two equations together, the 5x's cancel out. Negative 3y plus 6y is 3y. And negative 22 plus 34 is 12. So I have 3y equals 12, divided by 3, y equals 4. Now I can substitute 4 in for y into either equation, and it doesn't matter if it's the original form or it's my manipulated form. I have a tendency to put it back into the original form so I don't make a mistake somewhere. So I'm going to plug it back into equation 1. 5x plus 3 times 3 equals 22. So 5x plus 9 equals 22. Subtract 9. 5x equals 22 minus 9. Okay. 22 minus 9 happens to be, oops, I plugged in a 3 instead of a 4. No wonder this wasn't looking right. Go back up here. This should be a 4. Silly me. So let's erase all that part. So back to this, 5x times plus 3 times 4. I knew that didn't look right. So that's going to be plus 12 equals 22. Subtract 12. These will cancel. 5x equals 10 divided by 5 divided by 5. X equals 2. So my coordinate pair is 2, 4. And I can check that. 5 times 2 is 10. 4 plus 3 is 12. 10 plus 12 is 22. That works. 5 times 2 is 10. 6 times 4 is 24. 24 plus 10 is 34. That also works. So this is solving by elimination. Now sometimes you get equations where you can't just multiply by a negative. If I look at my third problem here, I have two equations here. Equation 1 and equation 2. And I can look at that and I can say, I can eliminate either x or y. It doesn't matter which variable I choose to eliminate. In this instance, I think it will be a little easier to eliminate x, because I know that 3x, if I was to look at this, 3x and negative 6x have a common denominator of 6. So what do I need to do to get 3x to become 6x? I need to multiply it by 2. So if I take the second equation and multiply everything by 2, it's already negative, so that when I add it, my x's will cancel out. So 3x times 2 is 6x, 4y times 2 is 8y, and 11 times 2 is 22. Oops, that's supposed to be equals. In my first equation, I'm just going to leave it alone. So I have negative 6x plus 5y equals 4. Now if I add these up, my x's cancel out. 8y and 5y is 13y, and that equals 22 plus 4 is 26. Divide by 13. Y equals 2. So now I can solve for either x or, actually, I can solve for x in either equation 1 or equation 2. I'm going to put it in equation 2. So I have 3x plus 4 times y equals 11. 3x plus 8 equals 11. Subtract 8 from both sides. So 3x equals 3. Divide by 3. X equals 1. So my solution to this system is 1, 2. Now, if we look at equation number 4, nothing's negative. So one of the equations will have to be multiplied by a negative number, and one of the equations will have to be multiplied by a positive number to either get x or y to cancel out. I think it might be a little bit easier in this instance to cancel out y, because the common denominator between 7 and 2 is 14. So I would need to multiply the top equation by 7 and the bottom equation by 2, one of which would have to be negative. So I'm going to eliminate my y's, and I'm going to take my top equation, and I'm going to multiply it by 7. I'm going to take my bottom equation, and I'm going to multiply it by negative 2. That way my y's will cancel out. 6 times 7 is 42, so I have 42x plus 14y equals 28. In my bottom equation, negative 2 times 10x is negative 20x minus 14y equals positive 16. Be very careful with your signs, your positive and negative signs. If you mess up one sign, it will mess up everything, and then it gets very frustrating. So my y's cancel out nicely. If for some reason you don't get a variable to cross out, you did something wrong. Start again. Maybe you forgot to multiply something by a negative. Maybe you found the wrong common denominator. I don't know, but start over so you can eliminate a variable. So 42x minus 20x is 22x. And 28 plus 16 is 8 and 6 is 14, 44. Divide by 22. X equals 2. Now again, I can plug it back into the first equation or the second equation. I didn't remember them this time, silly me. I'm going to substitute back into the first equation. So we have 6 times 2 plus 2y equals 4. So 12 plus 2y equals 4. Subtract 12. 2y equals negative 8. which means y equals -4. So my solution to this system is 2, -4. Now, not always will all your systems end up to be whole number answers. You will get fractions once in a while. So don't be alarmed if you get a fraction once in a while. But if you get everything as a fraction, you probably made a mistake. Because most likely they're not going to have tons and tons of fractions in these types of problems. Now, we can do real world problems with these, in other words, known as word problems, things that you would encounter in real life. Let's take a look at this equation, or this problem. 4 times a certain number is 3 more than twice another number. The sum of the first number and twice the second number is 5. Find the numbers. Okay, I have 2 numbers. For the lack of anything else, we have the first number and the second number. So let's let x equal the first number and y equal the second number, or a or b or p or q or whatever variables you choose. I'm going to let x equal my first number, and I'm going to let y equal my second number. Now I'm simply going to read my statements and see if I can come up with equations. Here's my first sentence. And I'm going to write that exactly as I see it. It says, 4 times a certain number is 3 more than twice another number. So I'm going to say 4 times the first number. 4 times a certain number is 3 more than twice another number. There you go. 3 more than means the other number has to come first. That's my first equation. Not written in standard form, but I'll deal with that later. I just want to get the equation down first, and then try to get to getting it in the standard form where I can use it. My second equation, if I look at my second equation here, it says the sum of the first number and twice the second number is 5. So that's what I'm going to do here. The sum means adding. The first number and twice the second number is 5. Literally, word for word, translate that straight into an equation. So we have 2 equations here. I need to get my first equation in standard form, which we've talked about. We did that last chapter. So I need to move my 2y over, so I have 4x minus 2y equals 3. And my second equation here is x plus 2y equals 5. Now if I was to add these together, my y's cancel out, so that's kind of nice. So these will cancel, so I will get 5x equals 8. You might go, ew, ick, we're going to get a fraction. Yes, you are. That's okay. You can get a fraction. If I divide by 5 here, x equals 8/5, or if you're so inclined, 1 3/5. Okay. Now, you have to substitute it back in. It's going to be easier to substitute it as an improper fraction, which is why I left it at 8/5 as well. I need to solve for y. And it really doesn't matter which equation I put it in. I'm going to put it in the second equation. So my second equation says x, which is 8/5, plus 2y equals 5. So I need to solve this equation. So I will subtract 8/5 from both sides. These cancel out, giving me 2y equals, well, 5 is 5 over 1. I need to get a common denominator here, which is 5. So this is going to equal 25/5 minus 8/5. So that's going to give me 17/5. That's 20, that's not 15, 17/5. 25 minus 8 is 17. So I have 17/5. But that gives me 2y. I don't want 2y. I want y. So I have to divide by 2, or that's the same as multiplying by 1/2. So these will cancel out, leaving me with y equals 17/10. Since this is a word problem, I don't answer it in a coordinate pair. I answer it in a complete sentence. So I'd answer it by saying my first number. The first number is 8/5. And the second number is 17/10. And of course, you can change those to mixed numbers if you choose, but you don't have to. And it's probably probably a little easier to leave them as an improper fraction, especially if you wanted to check them, because you have to put them back as an improper fraction in order to check them. Another word problem. The band sells cans of popcorn for $5 per can and mixed nuts for $8 per can. It's a fundraiser. They sell a total of 240 cans and receive $1,614. Find the number of cans of popcorn and mixed nuts sold. Well, as you can clearly see, we have two things, popcorn and mixed nuts. And because I don't like to use, lots of fancy variables, I'm just going to let x equal amount of popcorn. And y is going to equal mixed nuts. And that's going to be basically the number of cans sold. Now, we have to have two equations because we have two variables. One equation should be based on how much money they make. Because if they sell popcorn for $5 and mixed nuts for $8 and they made $1,614, that in itself should make up one of my equations. One of my equations is going to be based solely on money made, okay, on money. So I'm just going to write this. It's $5 per can for popcorn. So the amount of money I make from the popcorn plus the amount of money I make for the nuts, which is $8 a can, has to equal the total amount of money I make, which is $1,614. There's equation one, based solely on money. So equation two should be based upon the number of cans I sell, because it's the only other information they give us. So we have a total of 240 cans. Okay, so that's my second equation, should be the number of cans of popcorn, x, plus the number of cans of mixed nuts, y, has to equal 240. There's my two equations. One equation based on money, one equation based on the number of cans sold. Now I simply need to multiply out to get rid of one of my variables. And I could either multiply, equation 2 is obviously going to be multiplied by a negative number. I can either multiply it by a -5 to eliminate x, or I can multiply it by a -8 to eliminate y. It doesn't really matter, but I think I'll just go with -5 because it's a little simpler. So I'm going to keep equation 1. So I'm going to keep 5x plus 8y equals 1614. Equation 2 here, I'm going to multiply by -5. So I'll have -5x minus 5y equals 240 times 5 times -5 is -1200. My x's cancel out. 8y plus -5y is 3y. 1614 minus 1200 is 414. Take 414 divided by 3. And we will get that y equals 138. So we will need 138 cans of mixed nuts. So if I go back into equation 2, x plus 138 has to equal 240. I can solve and figure out how many cans of popcorn I need by subtracting 138. Okay, 240 minus 138 is 102. So I will need, okay, the number of cans of popcorn and mixed nuts sold. They sold 102 cans of popcorn and 138 cans of mixed nuts. As you can see, it is not hard to solve word problems once you've figured out how to set up the equations. And the equations aren't difficult if you look at the information given and try to rationalize what type of information you're given and how is that going to help you. This is solving equations by elimination.